College Algebra. This is lesson 5.1, and in lesson 5.1 we're going to solve systems of linear equations. So this lesson is going to take you back to Algebra 1 and Algebra 2. We're going to start with systems of two equations, and by the time we're done with this lesson, you'll be solving systems of three equations with three unknowns. So we're going to start with this first one. We're just going to do substitution. Now there's various methods for solving a system. You have substitution, elimination, graphing, and then there's a host of ways using matrices, and one of those ways is Cramer's rule. We'll be doing that in lesson 5.3. Okay, so we'll cover these two in lesson 5.1. Now you need to pay attention to the directions in your homework. If they say to solve with substitution, then that's what I expect you to do. If they say to use elimination, then that's what I expect you to do. Same thing goes on your tests and quizzes. You need to solve the problem in the way that they ask you to. If it just says to solve, then you get a choice. Okay. So if I'm going to use substitution, I'm going to be plugging one equation into the other. So I'm going to go ahead and say x equals 1 plus 2y here. And then that's going to go in for x right here. Distribute. We get y is 2. Then we're going to take our 2 and we can just plug it in right here. And we get x to be 5. Now this represents a point of intersection at 5, 2. All right, so when your lines intersect, when they intersect at exactly one point, you will call the system consistent. And we call the equations independent of each other. Now this information is in your textbook on page 498. For example 2, I'm going to go through the process of elimination. So the idea is to eliminate either the x's or the y's. And I'm going to just go after the x's. So I'm going to take this top equation and multiply it by 2. When I do that, I'm multiplying by 2 on both sides. And then here's the second equation written underneath. If I add these two equations together, I'm going to see that I get nothing here and nothing here, so 0 equals negative 20. Well, that's a false statement. So a false statement is going to give you no solution. No solution means that the lines are parallel. We call that system inconsistent. The equations are still considered independent. Okay, let's look at this next one. Let's say I wanted to eliminate x again, so I would double this equation. Now when I add everything up, I get 0 equals 0. That yields infinite solutions. There's a particular way for you to write infinite solutions as a solution set, and I'll cover that here in just a second. Because you have 0 equals 0 and infinite solutions, we say that these lines coincide. In other words, one of these equations is a multiple of the other, or they're exactly the same line. So with that, we say the system is consistent. And the equations are dependent. Okay, now how do I write the answer when I have infinite solutions? So let's just backtrack a little bit. When I get an ordered pair, I expect you to write it as an ordered pair. When you get no solution, this is the notation. When you get infinite solutions, here's what we need to do. Your textbook is going to say to write the solution set with y arbitrary. That means we're going to write basically a formula to generate all the ordered pairs that fall on that line. Remember, these two equations name the same line. So what we're going to do is you need to solve one equation for x. So take either of your equations and solve it for x. What am I doing? I'm not solving for x, I'm solving for y. Let me start that over. Solve for x. Okay. Okay. All right. The next thing they're going to do is they're probably going to write that with a common denominator. Remember right here, your y is actually part of the numerator. When it sits out there, it's part of the numerator. So there's your x. So what we're going to do is we're going to say, okay, if y is arbitrary, this represents the x in my ordered pair. And y is just going to be y. So you've generated a set, basically a formula to find x given y, and if you plug a particular y value in, then that point is going to be on the line. So if I say, okay, y is 0, then my x would be -1/2. So -1/2, 0 is a point on the line. If I say, well, if y is 1, then my x would be, what, -1/4. So there's another ordered pair on the line. So you choose y, you find x, and you can do that infinite times. So this is just a formula, a way to write infinite answers with the y arbitrary. Again, your book's going to have you use arbitrary y, so you solve one equation for x. Once I do that, that becomes the x coordinate in my ordered pair. And then the other one would just be y. Okay, we're going to stop these notes right here, and on day 2 I'm going to walk you through how to do a system with 3 equations and 3 unknowns, and then we'll get into a few more problems. Actually, let's do this problem first before I stop you. With this one, let's get rid of your denominators first. So if you see problems like this in your homework, multiply everything, both sides, by your common denominator. that's going to get rid of your fractions. 3 divides into 12 4 times. 4 goes into 12 3 times. And then I have it equal to 48. If I clean that up, I can keep going after this, getting my x and my y on one side of the equation, and that would equal 46. If I take care of this one, multiply by 6, 2 goes into 6 3 times, 3 goes into 6 2 times, oops, there's a minus sign there, and that would equal 18. So then what you want to do is you want to take these two equations together and solve this system. And you would have your choice of elimination or substitution. If I went the elimination route, I might take the second equation times a negative 8. And then I would just finish it from here. Okay, so that's how you handle questions like that. You might see some of those in your homework assignment. Again, the steps would be to get rid of your denominators first by multiplying both sides by a common denominator, and then just working through the algebra until you can get it down to a reasonable system to work with. All right, we'll stop this video here, and then on the second video, we'll do systems of 3 equations with 3 unknowns.